our last problem, so let's go ahead and let's make our own unique little kind of question here, and then let's clear our kernel, quit it. There we go. So, strain Rosette, spin me right round. I have a piece of unknown and possibly alien, but clearly metal material. So metal, 100 times 10 to the 9 pascals. My Poisson's ratio is 0.3. Let's go ahead. Recently found in Utah, as seen before. So y is equal to 100 times 10 to the 9. My nu is equal to 0.3. Here we go. I place a rectangular rosette and a delta rosette on this material. So I have a material like this. Oops. Press down too hard on my A, B, and C for my rectangular. And let's kind of read through the problem. So the B arm of the delta rosette is offset from the C arm of the rectangular rosette by a 38 degrees counterclockwise rotation. So basically my, I'm going to call here, which is my B prime for my delta rosette. So my delta is going to be in my green, and my red is going to be my rectangular. So if I look at my delta rosette, this angle here is 38 degrees from here and here. And then I know I have my usual, again, from here and here, this would be 60 for C, and then I have some angle here for A prime. A prime, C prime, B prime, etc. All right, let's keep reading. The strain in the C arm and B arm of the rectangular rosette is 81 and 151 microstrain respectively. So my E sub C is equal to 81 times 10 to the minus 6. My E sub B is equal to 151 times 10 to the minus 6. All right, let's keep reading. While the strain in the C arm of my delta rosette is 25 microstrain, or minus 25. So E sub C prime, I'm going to call it, is equal to minus 25 times 10 to the minus 6. All right, so I need to calculate the strain measured in all arms of these strain rosettes. I need to find out the principal stress and strain for this material, maximum shear stress, and I need to figure out what's the rotation to get to the principal stress and the maximum shear stress state. All right, so let's go ahead and look at this problem. So we are given, really it's all about how do we want to, or where do we want to pick our reference point. So if we draw, let's go ahead and let's draw a little bit. Actually, let's do it in a different color. So let's scroll down here. So we have basically, I want this color. So here, this is gamma, my engineering strain over 2. This is my here. So we're going to have a point, basically in microstrain. So 151, 81, and then minus 25. So we'll have lines here, 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 and then our circle is going to be somewhere here. So you know what? I'm going to go ahead and I'm going to pick, just for this particular problem, this is my center. My radius is going to be here. And then I'm going to look at this 2 theta. So I'm going to pick my reference point as my E sub B arm of the rectangular rosette. So that's going to be my reference point, E sub B. And I'm going to do everything else kind of related to that. So let's go ahead and let's figure out the rest of these values, right? All right, so let's go ahead and, yeah, let's do it. So I want to figure out my center, my radius, and my 2 theta. So that's kind of the clear values that I need to kind of get instantly for this equation. So I have 3 unknowns. I need to figure out what's my center, what's my radius, and what's my 2 theta. So if I'm using my B of my rectangular as my, so it's just going to be equal C plus R cosine of 2 theta. So, and that's, we already know what E sub B is. So that's going to be my first equation. So I need to solve E sub B, set that equal to C plus R times cosine of 2 times theta in degree mode. Here, here, and all right. So that's the first equation. So B is my reference. So now to get to 81, because that's in my C arm of my rectangular, is that the angle between B and C. So I need to rotate essentially from here to here. So from B to C, that's going to be 45 degrees counterclockwise. So that is going to be, E sub C is going to be plus 90. So that's going to be E sub C, oops, E sub C, and that's going to be 2 theta degree, 2 theta plus 90. There we go. And then I need one more equation. So the other strain that I know for sure is my C-arm here. So I know that this angle between here and here is 45, and then 38, and then 60. So I need to kind of add all those together. So my EC prime is going to be equal to, again, let's go ahead and let's copy this equation. EC prime is going to be equal to, all right, so let's go ahead and let's do it plus 2 times. So we're going to go from B to C, so that's 45, plus 38, plus 60. There we go, 2 theta, 2 times that rotation. So now I'm going to solve for my C, my R, and my theta. We're all in degree, everything's copacetic, everything is good. Let's look at this numerically, and voila! So this is my center. So my center is this. So C equals this. That's strain. Now, again, this is the angle that I choose, right? The angle that I choose here, I want the center because I'm starting my reference point as my B, the 151. So I need the positive radius. So this guy. So this angle especially. So here's my R. So my R is equal to this. And then again, my theta, my angle, will just be this. Oops. So this is my theta in degrees. I'm just going to get this. So theta is equal to here. So minus 13 degrees again. So I need to rotate that angle. So now we could kind of start to really fill out this question. Actually, so there we go. So I got my C, my R, my theta. So now I can kind of write the rest of these values. So let's go ahead and let's kind of knock out the rest of these. Again, we chose B as our starting point. So we don't know what EA is. But my EA is just going to be simply, again, so if I want to rotate from B to A, that's going to be a clockwise rotation. So that's going to be C plus R times cosine of 2 times theta plus, or actually minus 90. Because again, we're going clockwise. And let's put that in all in degree, and voila. So that's my EA. What about my EB prime? So again, I'm going to do the same thing here. EB prime. So EB prime, again, from B. So we're going to go from B to C, that's 90. So again, clockwise. So that's going to be a plus. Let's just copy that same format. So we're going to go from plus 2 times 45 plus 38. So that's going to get to there. And then my A prime is going to be, again, C plus R. Let's just copy this over here. So now this is the harder, or not the harder one, but we're going to do a little bit of. So this is offset 38. So what's the remaining angle from, basically, so this is offset 38. So now this has to be, what is it, 60? This needs to be 20. This angle between here and here, this is going to be 22 degrees, right? Yeah, 22, 60. So the angle that's left is going to be, basically the rotation here is going to be 45 minus 22, right? So I need to go clockwise 45 minus 22 to get to there. So I need to go 2 times 45 minus this 22 degrees. But again, still positive because I need to go there. And that's it. So those are all those values. And again, you can just see it's kind of just geometry related. Fantastic. So we got all the strains. What about the principal stress and strain for this material? Well, we know that the principal strain is just going to be E1 is going to be C plus R. E2 is going to be C minus R. And then my sig1 is going to be equal to 1 divided by Y times, oops, sorry, I'm going to solve it. Solve for E1. E1 equals 1 divided by Y, sig1 minus nu times sig2. And then I'm going to solve this system of equations. E2 is that equal to 1 divided by Y times sig2 minus nu times sig1. And here we go. And let's solve for sig1, sig2. Boom, we've got that right there. So we're good to go. And the other thing, what's the principal stress? What's the maximum shear stress? So again, that's my sigma 1, sigma 2. Again, assuming that there's no other kind of stress. So my circle would just be this minus this. So basically the radius, plus this value. And then I divide that by 2. Because then that's my Mohr circle. I'm looking at the radius. So that'll be my maximum shear value. And so now the question is, what's the rotation to get to the principal stress state? So we see here that we are not in our principal strain state, right? That would just be if we were lying flat. So we need to rotate this, basically if we're, imagining it from this angle. So we found that angle previously, so we need to rotate basically clockwise that angle of 13 degrees. So to rotate to the maximum shear stress state, I needed to go 45 in the opposite direction. So minus this. So I need to go here. And then voila, 31 degrees to get the maximum shear. That's it. That's all. Again, we went through this quickly, but we've gone through the problem sets. We've gone through our problem sets and our basically other in-class activities and problem set 7, problem set 8, and there's quite a few other practice exams up as well. So good luck on the exam, and I'll see you at the review session. And then congratulations on completing Engineering 110. Thanks, and have a good one.